Hello everyone, I am Shomesha Shanapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So in this class, we will solve one numerical on basis of, in case of simply supported beam, while application of three different kinds of point load is there. We have already discussed how to find out shear force and bending moment while application of different types of load is there. So here we will solve one numerical. So let's solve that. So to solve the numerical, we just need to find out our reaction forces. Okay. So here let's take this as point B. So here A and B are the end supports of simply supported beam. So the reaction force will apply here at the end supports. At A we will have the reaction force RA, and at B we will have the reaction force, that is RB. So our work is to find out the reaction forces first. To find out RA and RB, what we need? We know that the upward forces and the downward forces is similar. So RA plus RB will be none other than your 3 point loads, addition of the point loads. So it will be 4 plus 10 plus 7. So RA plus RB is going to be 21 kilonewton, right? So if we find out movement at any point, like at A or at B, so let's find out movement at point A. Movement at A will be, movement is nothing but your force into distance. So RB into distance, that is from this point to this point, that is it will be 8 meter. So RB into 8 is equal to 7 into 6 plus 10 into 4 plus here 4 into 1.5. Okay. So RB will be 42 plus 40 plus 6 divided by 8. We have RB, that is 88 divided by 8, and here RB is equal to 11 kilonewton. Okay. So if we put this value here, we can find out RA value. So RA is equal to 21 minus 11, that is RA equal to 10 kilonewton. Now we have the reaction forces RA and RB. Okay. So now our work is to find out shear forces. These RA and RB nothing but the shear forces at point A. So here we will have shear force, that is 10 kilonewton, and here we are having 11 kilonewton. Okay. So to find out shear force, so how to find out? We have the shear force, we have the reaction forces here from point B. So at point B we have 11 kilonewton, as it is in this direction, so we will have minus 11 kilonewton. Okay. Shear force at B. equal to minus 11 kilonewton. So, shear force at C. Here you can see the force is 7 kilonewton and here minus 11. So, minus 11 plus 7, that is minus 4 kilonewton, right? Next what? Shear force at point D. You have already seen that minus 11 plus 7 and at D we are having 10 kilonewton. So, plus 10, that is 6 kilonewton, right? Here shear force at E, this 6 plus, here you can see we are having at E 4 kilonewton. So, 6 plus 4, that is 10 kilonewton. Okay. Next, shear force at point A, that is the reaction force RA is equal to 10 kilonewton. Now we have the shear forces at A, B, C, D, E. So now we can put these values and can draw the shear force. So before drawing the shear force diagram, let's find out bending moment. So to find out bending moment, what do we need? You can easily remember, in calculation of bending moment, we only need the shear force and the perpendicular distance among them. Okay. So, we will start from point B. Sorry. Here, bending moment at B. You can see here, we are having the shear force here minus 11 and the distance from B to B is 0. So, we will have 0 there. Bending moment at B, that is minus 11 into 0 equal to 0 kilonewton into meter. Right. Next, bending moment at C. The very similar process, that is minus 11 multiply with the distance 2 meter. Minus 11 into 2 plus 7 into 0, that is 0. So, we will have, here you are having the reaction force that is in positive, so positive, that is 22 kilonewton. Okay. Bending moment at D. So, here you can see this distance is 4 meter and 11 into 4, okay, minus 7 into 2. So, 11 into 4 minus 7 into 2, that is 44 minus 14. We are having 30 kilonewton into meter. You need to remember the units always. Why? Here the big difference between shear force and bending moment is only unit. Why? Shear force is only addition or multiplication of what? Your forces. But in case of bending moment, we are multiplying the distance with forces. That's why force into perpendicular distance, kilonewton into meter. Okay. Next, bending moment at point E. So, to multiply the whole distance, this to this. This is 2 plus 2 plus 2.5. Your 6.5 into 11. So, 11 into 6.5 minus 7 into this distance. this to this. So 4.5. 7 into 4.5 minus what? 10 into 2.5. So bending moment at E will be 15 kilonewton into meter. For each check, you can calculate these things. Okay. So bending moment at A will be this whole 11 multiply with 8 minus 7 multiply with this to this, just minus this 2 meter and this whole 4 plus 2 6 minus 7 into 6 minus 10 into 4 minus 4 into 1.5. If you calculate this, you will have 0 kilonewton into meter. Okay. So you can easily remember that bending moment at end support is going to be what? Always 0. So for recheck you can calculate this. Now we have the shear force and bending moment at different points. So let's draw the shear force and bending moment diagram. Here okay. So this is for shear force diagram and this is for bending moment diagram. So first SFD. We know shear force at point B is what? Or this here shear force at point B. We already have that. Next, here at B we are having minus 11, then minus 4, 6, 10, 10. Okay. So here minus 11 kilonewton at point B. Okay. So we can join this and at point C we are having minus 4. Minus 4 kilonewton. Okay. Next, at point D, we are having 6. That is in positive sign. 6 kilonewton. Next, we are having at point E, 10 kilonewton. Also at point A, we are having 10 kilonewton. If we join this, we can have whole things here. These to this. Next, from here to here, this. Here you are having 6 kilonewton. Let's increase this. Okay. As this is the shear force diagram for simply supported beam, so we will have simple line. Okay. This for B, here C, you can write D, E and A. Okay. Next, BMD. How to draw? At end supports, here at point B we are having 0, and at C, that is 22, 30, 15 and again 0. So, first here 0 kilonewton into meter, then here 22 kilonewton into meter, at point D we are having 30, this as 15, and at last here 0. If we just join this by using simple line, here is the bending moment diagram. You can okay. This is your SFD, and here this is the BMD of this simply supported beam, while the application of 3 different values of point load is there. So, in this class we have find out the how to find out shear force and bending moment, and also draw the SFD and BMD. In our next classes we will solve various numericals and use lots of different kinds of loads to know better way. Okay, thank you so much.